Mm-hmm.
Can the same letter be picked twice, or the same name be picked twice?
No, I would not pick Delaney and Delaney to be MVP.
Okay.
If I pick Delaney, she's been picked, so I won't pick her again. Even if you think you deserve it, Delaney. You can only get it once. Now you know how Delaney really feels. She's like, I want all the MVPs. So if order matters, me picking Alyssa and Bo would be different than me picking Bo and Alyssa. If order mattered, like you wanted to be picked first, then A, B, and BA are two different outcomes. But in the second question, if order doesn't matter, Alyssa and Bo and Alyssa, isn't that the same two MVPs? So you would really only count that one time. So that's what I mean by order matters or order doesn't matter. If it's different or if it's really the same group. The factorial. Okay, but then I would be choosing everybody. Like my favorite. My list of favorites. 4, 3, 2, 1. But I'm only picking two MVPs. So think about that. You're not using all the options. What about Alyssa and Delaney, right? Yeah, so like the sample space might be helpful here. If you use the letters A, B, C, D, kind of list out the ways you can make two pairs of those letters. It isn't 24, so it's not that many.
There's Alyssa and Bo. It's just three.
Okay, help me out with the order matters. Like I'm asking for a sample space. So remember back to 10.1, a sample space is like when you actually list out all the possible outcomes. Like the sample space for rolling 2 die, when we list all 36 pairs of numbers. What else is possible besides Alyssa and Bo and Alyssa?
Yeah.
Yeah, Maddie?
Alyssa and Cole.
Okay, Alyssa and Cole, which also Cole and Alyssa. Or Alyssa and Delaney, which would also be Delaney and Alyssa. If order matters, those would be different, right? Okay, because like Delaney might feel bad if I choose her second. Like, why didn't Miss Cronky pick me first, right? Feelings. Okay. Any other pairs? Okay, Bo and Delaney. Delaney and Bo. Bo and Cole, it was, and then Cole and Bo.
And then Delaney and Cole.
Delaney and Cole, and Cole and Delaney, right? So I'm kind of like keeping them a little bit in order there. Okay. Okay, so how many total outcomes were there if order mattered? 12. And some people got the number of outcomes by doing a calculation. What calculation did you do? 4 pick 2. Permutation of 4 items, pick 2 at a time, right? Because like order matters. So there's 4 ways for me to pick my first MVP. There's 3 ways to pick my second MVP. And we don't care because no one else gets a high five. Okay, now, what did you find out if order doesn't matter? It cuts it in half, right? Because if order doesn't matter, this is the same group. This is the same group. So we have 1, 2, 3, 4, 5, 6 different groups, right, of people who could win. And so this is what we're concerning ourselves with today. What happens when the order doesn't matter? Okay. Now, you might be able to tell, like someone, I think whoever that was said it went in half, right? So we took really a 12 divided by 2. What we're actually doing is taking that permutation of 4 items picked 2 at a time, okay, where order matters, okay, and then down in the denominator, you would have to divide off the repeating sets. The sets where it looks the same but it's in a different order. In this case, when I picked 2 students, that number was 2. Let's just think about, and you don't necessarily have to write this one down, but what if I picked 3? Order doesn't matter. Okay. How many repeating sets of 3 students would there be? You can maybe like just take a guess in your mind. Okay. So let's just pick the first 3. Let's say I choose Eleni, Bo, and Cole. Sorry, Delaney. Okay. How many ways can we rearrange ABC? CBA, EAC, ECA, ACB, and CAB. Okay, so maybe in your head when I said, well, how many repeating sets would there be when you pick 3 students, maybe you were thinking 3. Because when there were 2 students, there were 2 repeating sets. But actually, when there's 3, there are 6 repeating sets. If it was 4, there'd be 24 repeating sets. If it was 5, there'd be 120 repeating sets. Does anybody know what math calculation I'm doing right there? I'm not cubing it. 5 cubed would be 125, not 120. The exclamation point, the factorial, right? 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2 times 1, which is 6. That's what we're seeing right there with the 3 people I picked. 4 factorial, there would be 24. I'm just not going to take the time for us to list out A, B, C, D in different orders 24 times. Okay, because it gets bigger and bigger. So you divide off your repeating sets. What we really divided by right there is 2 factorial. So today we're going to be talking about something called a combination. And the combination is the same thing as a permutation, except order doesn't matter. So it's really like the number of groups that can be formed when order doesn't matter. And we can use the same permutation formula we got yesterday, n factorial over n minus r factorial, but we just have to divide by an extra r factorial, because that'll divide off our repeating sets. So I'll give you that formula here in just a little bit. Okay, in that section, make sure you write something about a combination. It's a selection of items in which order does not matter. Yesterday when I defined a permutation, I said it was an arrangement, not a selection. So those can sometimes be keywords that you can use to tell the difference of items in which order matter. And here we say order doesn't matter. So make sure you like highlight, star, underline, order doesn't matter. Okay, where you have space for a formula, a combination of n items taken r at a time, we can say NCR. So now you'll have to decide, should it be an NPR or an NCR? Your choice is determined on whether or not the order mattered, right? So you have to make that decision if order matters or doesn't matter. Okay, and you remember this is our formula for the permutation yesterday, n factorial divided by n minus r factorial. But in that preceding example, it wasn't just the permutation of 4 pick 2. We had to divide off the repeating sets. It's the number that you pick factorial. That's repeating. So those are your repeating sets. Again, right now you're really going to rely on your calculator technology to do your NPR and your NCR for you. You don't necessarily have to have this formula memorized, although later on you might utilize the formulas for other things. I think where my little arrow went. You don't necessarily have to rewrite the formulas, but if you want to compare the formulas in the columns, you can. I would definitely write something in the 2 columns as a comparison. Permutation order matters. Combination order doesn't. The formulas are exactly alike, except for combinations have an extra r factorial in the denominator to divide off the repeating sets. The sets where AB and BA look the same. Below that, I have some like keywords that can be helpful. Oh, I got more than I thought. Probably added to it over the years. You can write down some keywords for each of those. When you're like reading through those lists of keywords, think about how the words on the left might imply there's an order. And that the order actually matters. So arrangement implies order, like the seating arrangement in the room. You can't just come in here and sit anywhere you like. You have a specific seat, so your order matters. If a sub were to come in, they would want to know it's you in that seat. There's an extra R factorial right now. Another one that kind of gets people in that permutations column is the schedule. If we ever talk about how many ways can you schedule something, that's going to be a permutation because your order matters. Think about your own class schedule. You might have 6 or 7 classes, but you can't just go to them in any order that you want, right? You have to come to honors algebra 2 during first hour. So your order matters. You follow the same order every day. Okay, schedule implies order matters. In combinations, when you look at those words, they're just implying like selections of things, but the order isn't really important. Committees, choosing, selecting teams, groups. Okay. You don't have a specific role that you're playing in that problem, so then it would be a combination. Okay, so the next little piece before we get into some examples is just really quickly about like strategies for counting problems. Okay. This is probably my best hint to you, and then I would say like think about it on your own time. Like when you have all the counting problems mixed together, how do you decide when you should do what? If you have a lot to choose from, or if you have many choices, or many, I'm going to say have a lot to choose from. A lot of items to choose from. So if you have if you're reading about a scenario and think about the scenario you created with your group, maybe some of you used the NPR at the beginning of class today to create that problem in your warm up. So if you're saying you have all these students to choose from, or you have all these classes to choose from, but you're only going to pick a select few of those, however many that may be. I'm only going to pick 2 students, or I'm only going to pick 6 classes for my schedule. When you're not using up all your options, that's a good time to be like, this is a permutation or a combination. How do you determine between NPR and NCR? Then you ask the question whether order matters. Okay. Remember that there's that other counting method in the mix, the fundamental counting principle. So like a license plate problem, okay, or like the sandwich problem. That's when you have to make a lot of decisions, right? I have to pick a meat, I have to pick a bread, I have to pick a cheese. So then I just multiply all the ways I can do those individual events. But like the strategies for counting problems, that's good for you to think about when you're doing your homework tonight. Like how do you decide from one problem to the next which type of method you'll use? Sometimes there could be overlapping methods and sometimes not. So what I'd like you to do right now is I'm going to give you a little bit of time. Do as many of the examples, kind of like think about what your setup would be. And more important than the actual number answer on this one is I'm going to say the setup. So we'll kind of go through and see if we agree. Was it a permutation? Was it a combination? Was it a factorial? Was it a fundamental counting principle? So kind of talk with your podmates about that. Are you guys comfortable there's an NCR on your calculator? Okay, it was where you found the NPR, or it should be like right next to it if you have a separate button for it. So go ahead, read through those examples on the back. We'll come together in a few and see if we agree on the setup. Most important is, can you choose the right counting method or unappropriate counting method? Sometimes there's more than one. Yes, alphanumeric means it could be a number or a letter. Yes. Yeah, and when you write them, Carson, I won't take off for this, but you actually don't have to write the N and the R. The 12 is the N, the 3 is the R. May I ask you about your presses? Sorry, presses for the one on the top.
Well, because there was 12 and there's 3.
Yes. So you're only choosing a few of all the toppings offered, right? So you know it's going to be an NPR or an NCR. Do you know why you chose NPR?
Because it probably would have said
Because I went like without order which the toppings are.
So you're saying it does matter or it doesn't? Okay, which, yeah, order doesn't matter. Which one is that?
Oh, that's the C.
That's the C. Very good. About that one on the top. Why did you choose? Excellent. So we're only supposed to use of the 12 that were actually allowed. And so when you do that, you could have an NCR or an NCR. What's the difference?
They just kind of waited till I was done.
you guys choosing permutation, you're telling me the order of my 3 toppings does matter. Do you agree with that? No. Does that make sense? Like before we would always just do NPR because that's all we knew. We knew it was going to be NPR, but now we have NCR in the mix. And so when you see those problems when you're choosing your review, you'll have to decide, does the order matter or not?
No, because if you're picking topics.
Okay, so we're gonna see.
How many different combinations?
Well, would your order
So
matter
order doesn't
when you
matter.
type your
So then
username
you see
in?
Yeah.
because you see
Yes, it
order.
would. Right, you can't just like, if your name is Jayla, and that's, I don't know, that's more than 4, but like you can't just put your letters in any order. I know. So there are 4 choices for your username, right? I think the question here, because like I said yesterday when we did the license plates, passwords, usernames, they're all kind of the same one. I really don't think about them as NPRs and NCRs, I think about them as fundamental counting principles. Because like sometimes you're allowed to repeat things, so then you wouldn't be counting down an NPR. So if it's a username, a password, license plate, I would really use them.
Probably do like 26 or 30.
My ceramics teacher hated me as a student.
And you
Loved me as
have
a
to
person.
like your
Isn't it just
rotations. Because if you're looking at as your
Because
notes,
you
it's
can
going to be a question of how did I get
You can repeat the characters.
that's one part and then even the number.
What do you do
Oh,
like this
I'm
one
talking about
now?
the second one.
No, yeah, like,
Yeah, I'm talking about the second one. So example 3.
Yeah.
Yeah, so you can, there's 36 possibilities and then another 36 possibilities because you're
Okay.
allowed to repeat things.
yes.
And then that
Alphanumeric means it could be a
No,
letter or
factorials
a
you can't repeat
number.
things.
So then you make traces.
You can still do 36 characters each time. But that, Mrs. Crosby,
Yes.
for example 3, are you allowed to repeat the same character?
It sounds like it because
So
they
then-
didn't tell me I couldn't.
I just did.
Then do 36.
I'm going to interrupt
Yeah, I'm
so that we can kind of run through some of them. You may not have gotten to all of them. That's okay. I know as I walk around, some people, you're using your calculators, which I totally understand. These can tend to be larger numbers, but you might also want to write down your setup so that you have it later when you're like looking at it as an example. Did I choose an NPR, an NCR, or factorial, or whatever that may be? Okay, a pizza shop offers 12 different toppings. How many different 3-topping pizzas can be made? Well, 12 things are offered, but you're only picking 3 of them. That's an NPR or an NCR, but you have to choose. Does the order of your toppings matter? No, you don't call Domino's and demand that they put sausage on before olives. Okay, I mean, they might have a certain way that they make the pizza, but you don't usually ask for it in a particular order. So that's going to be a combination of 12, choose 3. Anybody calculate that? 220. Okay, so order doesn't matter in that example. We're only picking a few of the toppings that are offered. Okay, I'm mixing everything up. So example 3, you're creating an online username. I talked about usernames yesterday when we were working on the fundamental counting principle with the license plate problems. If you're doing usernames, passwords, license plates, phone numbers, zip codes, anything like where you're like having an order of numbers or letters, it's probably best to think about it in terms of the fundamental counting principle, because remember that like this group was asking, there are occasions where you're allowed to repeat the letters or digits. So if you're using the permutation, that's the one that would like count down, right? So I saw a lot of people as I was walking around, we have 36, pick 4. That would mean that each alphanumeric character had to be different. I was not allowed to repeat. Does example 3 say that I can't repeat? No, it does not. So I would say for my 4-digit username, I have 36 options for the first, and then I have 36 options for the second, 36 options for the third, and 36 options for the fourth. You could use the permutation. I do agree that order matters when you're typing it in. So you could use the permutation 36 pick 4 if it said no repeats, like we did in that license plate example, the second one. So you could also type this in as 36 to the fourth, which I imagine is a very large number. Okay. So I'm not going to write that one on the board.
We have this same answer for the and doing the time, so what makes it different from order or not order?
You are getting the same answer?
Yeah, as the 36, 36, never mind, I put in 36 there, but
Yeah.
never mind.
If it was 36, 35, 34, 33, because you were not allowed to repeat, I do agree that that is the same as the permutation 36 pick 4. However, you have to be careful on license plates, passwords, usernames, telephone numbers, zip codes, anything like with words or like digits, okay, in a particular order. I would treat that like a fundamental counting principle in the case that repeats are allowed. Okay? Okay, example 4. 9 of your friends want to go to the Taylor Swift concert. You'll only have 5 additional tickets. How many different groups of friends can be chosen? Are you picking all your friends? Sadly, no. You don't have enough tickets. So you're going to do like an NPR or an NCR. Does order matter? Not right now. I mean, again, Delaney might be hurt if you don't pick her first. She'll feel offended that she wasn't your top choice. But in the end, order doesn't matter. So it's a combination of 9, choose 5. You probably have 6 tickets, but 1 ticket, of course, is for you, right? So you would be picking the other 5 tickets. Okay. When you get to the concert, and it'd be like our movie theater example, and you have to go into the seats. How many different ways can we put our friends in our seats at the concert? Who sits next to who? Then order would matter in the seating arrangement.
Would you say that given the fact that the end of the problem ends with how many different groups of friends can be chosen, is that like another big thing?
That's like a key word, yeah. So sometimes if it asks about arrangements, you can assume it's a permutation. Or how many orders of something, that's a permutation. You have to be careful, especially like for the ones that people turned in to me today with their groups, whether or not, like who wrote it, because you might say how many combinations, but you really need orders. But yeah, sometimes the keywords can be helpful. Okay, I'm going to give you your homework assignment. It's a worksheet tonight. So all the different types of counting are mixed together. Permutations, combinations, you could use factorials. You might use fundamental counting principle. Is it the front and the back? Yeah, okay. They're not too terribly long.